Good afternoon, everybody. Thank you for joining us for today's session. My name is Bob Boulay. I'm one of the senior solution engineers here with StarWind Software. And today's session is really going to revolve around using iSCSI SAN software to build out your shared storage and SAN environment. Session's going to run about 40 to 45 minutes, hopefully, and that'll leave us some time for some questions at the end. In terms of the questions, I would encourage you to go ahead and type them directly into the GoToWebinar user interface. Get them in there. That records the question for me as well. So any questions that I don't get to at the end, I'll certainly be following up with you on a one-on-one basis to make sure we get you an answer to your question. So if we don't get to it here live, we'll certainly follow up and get back to you on a one-on-one basis. Let me go ahead and dive right into the presentation today. Essentially, just to give you a quick overview of what we're going to cover. And essentially, we're going to be doing this in two parts. The first is going to be a series of PowerPoint slides where we're going to talk about, an overview of SAN technology, traditional fiber channel type of SANs versus iSCSI SAN, SAN versus direct attached storage, and then transition into why iSCSI. And throughout the course of the presentation, I'll be weaving in the benefits of using software as a SAN alternative or as an alternative to building out your SAN. And making sure that you have a solid understanding of the benefits of the software-based solution combined with a customized hardware solution, and really all the benefits and flexibility that come along with that. Some of the application advantages of shared storage. As we move into talking a little bit more about outside of sort of some of the high-level benefits of going with shared storage. We'll get into some of the more application-specific and talking a little bit about, things like a Hyper-V or a VMware type of environment and what benefits come to the table to rise to the surface when you start talking about a shared storage alternative for use with those types of projects, outside of, as I'd said, just the general benefits of SAN versus direct attached. And then we're going to transition over into a live demo portion where I'm going to walk you through the steps that are involved in terms of building out or setting up the software, and take you through some of the different ways you can go about creating storage repositories that can then be passed along to those initiators or those application servers, if you will. And then we'll once that portion of it's done, I'll actually show you a little bit of this working in a live lab. So I've got a VMware demo, and I've also got a Hyper-V demo that's been set up as well. We can actually show you how that works and what that looks like. And again, hit on some of the benefits that you're going to derive from those particular platforms when using them in conjunction with shared storage. And then we'll do a wrap-up with Q&A. And as I said, no need to wait to the end to sort of type those questions in. You can certainly feel free to type them in as we go. But with that, let me go ahead and get started. Now, I always like to start these discussions out, and any of you that have heard me speak in the past, this will be a very, very familiar slide. And this actually adds, there's a little bit more that gets added to this, in that, we're sort of focusing on not just, a different protocol outside of fiber channel, but also, we're talking about maybe a different way of building out, a shared storage environment using software, that is, versus some of the hardware-based iSCSI solutions. But I always like to start off with sort of the traditional, and, this is, by far not the only option that was available prior to iSCSI coming along. There were always options, but this is something when people think SAN, they think this type of setup. So a fiber channel-based disks, a fiber channel switching technology, along with proprietary fiber channel HBAs. All of this equipment and all of this, this sort of infrastructure will serve you very well. And for those of you that are out there that are using this, you can certainly attest to that. This is something that's tried and true, something that does work extremely well. So we're not here to tell you that somehow, using iSCSI and specifically software iSCSI is in some way a better alternative to fiber channel from the negatives perspective, or looking at fiber channel and sort of tearing it down. I think that, one of the things that the iSCSI market has really sort of tried to do, over the course of the last several years, is really to bring the costs that are associated with getting involved in a shared storage environment down, or putting some downward pressure on being able to not only get this equipment in-house, but also the ongoing setup and management of this equipment as well. So if you have a look here, obviously this is all of the, and I've got dollar signs next to the expensive pieces. And I mean, I don't think anyone could argue that well, this is a fantastic solution. It is very expensive. And I can't speak for everybody, but I can tell you that in most of the shops that I've worked in, and I've been a small to medium-sized business guy pretty much my entire career. When I haven't worked for, sort of software companies or startups, I've been working for, I've done some work in consulting or directly for that sort of small to medium shop, the shop that maybe is servicing, 200 to 250 users, and, really is in a scenario where this is right at the fringe of what they can afford. In a lot of cases, prices them out of the market. Now, with that said, to transition over to, an alternative, which obviously looks strikingly similar, we start getting into the iSCSI-based SAN. And, again, I think that putting aside, any vendor specifics for a moment and putting aside, software versus hardware solution for a moment, and just really focusing in on the non-proprietary or sort of off-the-shelf aspects of the iSCSI setup. And so, we're really talking about, building this out on a standard gigabit backbone. So for those of you that have got this type of networking equipment in-house, or you can, certainly buy this stuff off the shelf, and ultimately set something like this up. Those of you that are, maybe making the move from gigabit to 10 gig, this is also sort of magnifies that investment, and that putting in an iSCSI-based SAN will allow you to go ahead and extend the benefits of 10 gig E over to your storage area network as well. But I mean, I think that the reality here is that we're talking about sort of commodity-based hardware to go ahead and implement something like this. Regardless of what these iSCSI boxes look like down here. Now, for the purposes of today's demonstration, what we're going to talk about are the options that you have down here versus, sort of an off-the-shelf hardware scenario where you can simply customize the hardware and use the software to go ahead and drive the storage. But ultimately, again, we're talking about, all standard gigabit, network adapters, standard gigabit switching equipment, and then ultimately when we make our way down to the iSCSI boxes, we're talking about a software-based solution, which is going to allow you to go ahead and build out your storage utilizing those standard server equipment. So you're going to be able to, if you're a Dell shop, if you're an HP shop, if you're a Supermicro shop, you'll be able to customize and build out your SAN around pieces of hardware that not only are you already familiar with managing, but you probably are able to leverage discounts from those vendors. You may even have some of this equipment in-house already. If any of you have gone through, say, a server consolidation as part of a virtualization project, some of that equipment may still be in service and ultimately could be repurposed for use as a shared storage device. And so ultimately, we're giving you sort of the best of both worlds here. We're giving you the ease of use and the real sort of ease of setup of, say, a NAS type device or a file level type of share, with the benefits of performance and manageability of a block level device. And so that's really sort of the best of both worlds when we talk about iSCSI, and then extending that over into the software iSCSI realm. We start getting into the discussion around the customizability, and one of the things that we talk about around here is having a solution to fit every budget. So basically, there's the software purchase, and that ends up being one aspect of this, and then being able to customize a hardware solution that's going to meet the needs of not only the applications that you're looking to support, but also is going to fit into that budget. Now, one of the things that we do talk a lot about here at StarWind, and I think you probably hear this from a lot of different vendors. Anytime you talk about shared storage, or you talk to a shared storage vendor, you're going to get the standard speech around, why should I come off of direct attached? And quite frankly, I think it's an important thing to cover, because I think we've all got somebody that we need to ask for this money for, and the value proposition has to be there. And of course, those of you that are going virtual, some of the high availability and fault tolerant features that come along with that virtualization platform are, quite frankly, they become extremely important, because now not only does a server going down represent loss of application, but a server going down could potentially mean loss of 4 or 5 different applications. And so, shared storage from that perspective and unlocking those features is, a pretty compelling scenario when you're looking at virtualizing. But to take a quick step back and really sort of, bring it back to, prior to, virtualizing, or if you're a customer that, is considering this for another purpose, when you look at the benefits of central storage management, basically taking storage and separating it out from that application layer so that you can manage it as a separate entity within your enterprise, I think is a very, very key point here. When we start talking about the efficiency of resource utilization, we start talking about having, maybe 5, 10, 12 different servers, all with a fixed amount of storage in them, and whether or not that storage is being utilized or not, potentially is a tremendous waste of resources. So you build out a server with the amount of storage you think it's going to need between now and, say, next year or 18 months out, and for that period of time, that storage just sort of sits there. Whereas if you're drawing from a central pool, you have a much more efficient use of these storage resources. You're in a much better position to add storage as you need it, as opposed to going out and buying tremendous amounts of storage that may sit around for 6, 8, 10, 12 months. The other piece there is to sort of take some of the pressure off of those application servers from a data protection perspective. So now, now that you've gotten down to a SAN technology, you're starting to talk about some of the disaster recovery and some of the high availability options that are available to you from a storage perspective, or from the storage layer, as opposed to dealing with them at the application layer. So I may be able to take instead of setting up things like database mirroring and setting it up across each and every single database that I've implemented, I may be able to go ahead and just mirror the data stores at the block level that are being utilized on my SAN to support my database environment. Much lower, cost in terms of overhead, lot less, fewer moving parts when it comes to the setup, and obviously less things to break. The other thing is things like snapshot-enabled volume. So, I'm going to be able to go ahead and protect my data at the block level, and using some very, very efficient technology where I can go ahead and schedule it for 2 times a day, 6 times a day, every hour, every 15 minutes. I can tell my SAN to evaluate the changes that have been made and create a restore point for me so I can roll back that volume. It takes a lot of the pressure off of the application server. You're not doing these things at the application server level. You're doing it at the block level. They become much more efficient, and you're able to spread the workload around. So obviously, moving off of direct attach to a more centralized storage management option obviously makes sense. And I think that one of the things that we want to talk to you about today is how to go about doing that, and sort of the best approach, and what's going to offer you the best overall flexibility and the most options when it comes to what you're going to be able to spend to get there. Now, obviously, one of the things I touched on earlier too was the application features that this unlocks, and of course, I think this is something that can't be ignored. I mean, it's one of those situations where, again, one of the beauties of virtualization is it allows you to run more applications on fewer pieces of equipment. But it increases the footprint of that piece of equipment if something were to go down, if something bad were to happen. And so, what the virtualization or hypervisor manufacturers have done is built in a lot of great features to be able to make sure that you can move these virtual machines around. They remain portable. They allow you to load balance across the servers that you have. If you lose a server, they'll go ahead and fail over to a second box. The one common thread in all of this is obviously shared storage is required. And so ultimately, the decision that takes place when you start talking about going virtual is, how do I get the most bang for my buck from a storage solution? How am I going to go through the process of getting or maintaining the ROI that's associated with virtualization, without having those numbers blown out of the water by an extremely expensive shared storage solution, which quite frankly is very difficult to live without. Given the fact that obviously you're taking a lot more risk per individual physical host based on the amount of virtual servers it will be running. So again, a very, very compelling argument to move off of that direct attached and move toward a more centralized storage management system. Now, that again, before we talk in too much depth around software versus hardware, that brings us or begs the question, why consider iSCSI? When you think about the options that you've got out there in terms of fiber channel, NAS, and then iSCSI sitting right in the middle, I think that there are a lot of things to think about when you start talking about an iSCSI-based solution. As I had said before, you're looking for the simplicity of setting up a file share-based type of scenario or a NAS-based scenario, but you want the benefits and the performance and the data level protection that you get with block-level devices. So I think that makes iSCSI a very, very compelling story. The other piece here, obviously, is the cost factor. And again, generally speaking, you're able to get into an iSCSI solution for considerably less than, say, a fiber channel scenario. So if you're a customer that's looking at this from the perspective of, how do I go ahead and get into a block-level shared storage device, and I've got to make a choice here, what's going to be a more compelling scenario of iSCSI versus fiber channel, and then ultimately what can fit into my budget? I think that things like the off-the-shelf hardware, the sort of non-proprietary aspects of the infrastructure that goes along with building out an iSCSI SAN is really compelling, not only just from an initial cost perspective, but from an ongoing maintenance perspective. And looking at this from the backdrop of if I have a server go down, if I have a scenario where a switch blows up, I can replace that, relatively simply without a lot of intervention from, a specialist, a consultant, or, a vendor. I can simply, manage a lot of 90% of the infrastructure that goes along with building out this iSCSI SAN can be managed in-house. And I think that, when we start to move away from, we start the conversation around hardware versus software solutions, we really then start to hit on the more of, not only just the commodity aspect of the hardware, but also the flexibility. So, as I'll show you here during today's demo, StarWind is going to help you virtualize those storage targets on top of, a Windows box. The hardware, from our perspective, makes no difference. You're going to be able to go ahead and build out and choose the type of disk that you want to use in terms of speed and RAID set to meet those performance metrics that you've got, and also what's going to fit into your budget. How you wind up networking it will be up to you. We're going to provide you with some guidelines. We're going to tell you what the best practices are, but ultimately, the type of network you build out to service iSCSI, again, you have a lot of flexibility there. So I think that iSCSI, in a word, offers that flexibility, not only from a hardware perspective, but also from a costing perspective. Now, one of the things that I do like to do, and as we talk about sort of what the iSCSI SAN might look like, how it works, I like to sort of show you a diagram of and sort of an albeit rudimentary diagram of a sample of this thing in action. So, and in this case here, I've chosen a Hyper-V cluster along with StarWind's high availability storage. Now, as you can see here, in terms of what this looks like sort of in your environment, again, this is a little bit more advanced than the original diagram that I showed you. However, as you can see, we've got a switch here that's dedicated to the storage. So, each one of these Hyper-V boxes, there's a network interface or network interfaces that is going to be dedicated to iSCSI. Generally speaking, you're going to find this in a scenario where you're going to go ahead and have 2 NIC ports for iSCSI utilizing MPIO to go ahead and take advantage of the load balancing and fault and get yourself some hardware-based fault tolerance. You'll also do some dual NIC configurations around the actual traffic or to build out the network that the VMs are going to use, and then ultimately, connect that up to the corporate LAN so that the end users will have access to it, and then a NIC for your heartbeat. So the orange piece there is going to be your cluster heartbeat network. Over on the StarWind side, obviously, as you can see here at the storage layer, we're talking about, again, utilizing multiple NICs in the storage box. So again, you get the fault tolerance and load balancing across these. A synchronization channel for HA. Now, the way that StarWind high availability works is there are two virtual storage devices, one that's going to reside on node 1 and one that will reside on node 2. Those two storage devices, via the Microsoft, in this case anyway, the Microsoft MPIO driver, will present as a unified or single storage device with multiple paths available to it. Now, what you'll do is you'll choose how the initiator interacts with this storage is really going to be up to the type of policy that you set. For example, in a round-robin scenario, it will go ahead and load balance the traffic across the multiple paths, and then data will leverage the synchronization channel here. So if a data block is written here, it's automatically synchronized here. If a data block, based on the load balancing gets written here, it's automatically synchronized here. What this does, and the way that we go ahead and do this from utilizing an MPIO type of perspective, is we ensure that if one of these boxes were to go down, there's no I/O timeouts that are associated with waiting for a service to fail over. There's no I/O timeouts, waiting for ownership to transfer from a failed node to a passive node. This is a true active scenario. Now, again, the benefits behind this from the perspective of building this out with a piece of software is that you're going to be able to customize what these boxes look like. And so depending on the nature of the virtual machines that are being serviced, you're going to be able to go ahead and really sort of make the choices around what you're going to spend on the hardware, from the disk subsystem, through memory, through CPU, through the networking. How robust does this need to be in order to service the types of virtual machines that are being utilized? And so, ultimately, again, the flexibility factor comes into play when we start talking about a scenario where you want to build out the shared storage. And this, I think, gives you a pretty good sense for sort of what this might look like and help you visualize what this might look like. Now, we're actually going to watch this in action here in just a couple minutes when I switch over to the live demo portion. Now, for those of you that are interested in high availability, which is just one aspect of the storage offering from StarWind, I thought I'd sort of funnel in on this a little bit closer here and talk about this for a moment. Obviously, when you're talking about high availability, you're talking about the ability to spread the risk out across multiple assets. So basically, in this case here, we've got two boxes running StarWind's iSCSI service. And ultimately, what we've done is we're creating, and I'll walk you through how this creation works. We've created a virtual storage device that sits on top of a physical storage platform on node 1, and we've created an identical device over on node 2. And ultimately, what happens is these present with the same unique identifier to the initiator side with the MPIO driver installed, whether this be a Windows box or a Zen box or an ESX host. All support multipathing, and all are going to see this as a single storage device where you're going to be able to decide the load balancing policy or how the I/O is issued down these multiple paths. But the end result is it is an active scenario. So there isn't a passive or standby node here. These are both active nodes in a storage cluster. And then depending on sort of which node the block gets written to, it ultimately gets synchronized over the synchronization channel onto the second node. So that in the event that you were to lose, say, node 1, let's assume for a second that you were off doing Windows updates. You could certainly bring this box down. Node 2 would continue to service the storage. When node 1 comes back up, it resynchronizes and then ultimately goes back to accepting active I/O again. And then you ultimately, once that's done, you can bring node 2 down for Windows updates as well. So again, very, very straightforward scenario in terms of doing that. And I think that the idea or the flexibility that's associated with that is going to come through when we switch over to the actual live demo portion of the program. So what I'm going to do now is I'm actually going to shoot into a live demo portion of this here, and to give you some background, I've chosen to demo this built on I've taken a box and built it out on a Server 2008. This is just a lab box that I put together here, a Server 2008 box that I've gone ahead and filled up with some disk, created a couple of RAID sets, and are now going through the process of creating iSCSI targets on top of those physical storage platforms that I've created. Now again, being a software solution, we can install on and work under any configuration that you might throw at it. So as long as the OS can see the drives, they will be available for shared storage. It's one of those scenarios where ultimately you wind up in a situation where you're going to really get the last word in terms of the physical makeup of this box. But just to give you some background on what I've done here, you create a small partition that's going to house your OS. A lot of folks, what they'll do is they'll create a small RAID 1 set that's going to go ahead and be mirrored and serve as the repository for their operating system. We're talking about Server 2003 or 2008. We also will run on the 2008 core as well. Once that's done, you will install the iSCSI software and then configure the remaining storage in that box into the physical volumes, using your RAID controller, the physical volumes that will act as a platform for your virtual storage. And then ultimately you'll use StarWind to create those virtual storage devices that'll act as iSCSI targets to your initiators. Now, to give you a sense, now this is the StarWind user interface, and I've simply installed this here, and I've got the service installed on a couple of different servers here that I'm managing from this single interface. Now, what I'm going to do to get started, now I've already gone through the process of obviously installing the OS and configuring the underlying storage. My next step here is to go ahead and add a target. So I want to now start the process of creating an iSCSI target that's going to be utilized by my application servers. Now, this is all wizard driven, so it makes it nice and easy. This is another nice aspect, and that once you've sort of configured that underlying storage, the physical storage, that's it. You don't have to worry about anything else. All you have to do is choose the physical storage platform, as you're going to see in just a moment, that these virtual devices will live on. So the first thing I'm going to do here is I'm going to create a target, and it's going to ask me for a target alias. So we'll call this demo 21 test 2. Now, it's going to give me a couple of different options here. And again, this is another major benefit of using software to build out your iSCSI solution. Now, I'm getting the choice here of what type of storage device do I want to use that's in this server to create my iSCSI target. What do I want to virtualize or create a virtual target from? Now, obviously, hard disk is going to be the most popular, and we're going to focus on that this afternoon. We also give you the option of creating an optical drive as an iSCSI target, or a tape device. And under the tape device, you have a couple of different options here. One is a physical, so basically we can create an iSCSI pass-through of a tape library that you might have. So if you want to go ahead and create a scenario where you want to pass through as an iSCSI target, a tape library to go ahead and run backups against, you can certainly do that. Or StarWind also offers a virtual tape option, where you're actually creating disk-based iSCSI LUNs that will ultimately be presented to the initiator, whether it be your backup server, like a backup exec, or an ARC server, something along those lines, as a tape device, so that you can maintain the management that you've currently got going on in terms of your backups, continue to present tapes without having to deal with the speed at which those things will run. So obviously you get faster, smaller backup windows, easier to manage because everything is on disk, and basically what you can do is do a a disk to tape type of scenario. What a lot of customers will do is they'll go through the process of presenting, say, a dozen virtual tapes, and then you can swap out the image files that present on those underlying virtual tapes, and ultimately just rotate those through and take the image file devices and ultimately put those off to tape, after the backup is done, so there's no impact to your backup window. But at any rate, let's focus on the hard disk aspect of this, and ultimately, the next option you're going to get here is, do you want to create a physical storage device? So for those of you that are looking to emulate, maybe one of the physical devices that's out there. So if you're looking to simulate what you might do with, say, a Buffalo type of device or a Netgear type of device that supports iSCSI, where you're basically going to go ahead and pick a physical storage asset within this box and simply create an iSCSI pass-through to it. So there will be no data protection, no storage virtualization. You're saying, I want to take RAID set A and I want to make it a target. You can certainly do that. The basic virtual device is, again, really the best way to think about this is almost like a Microsoft virtual hard disk. It's really a scenario where it's a physical reservation of disks. So if you create a 2 terabyte image file device, we're going to reserve you'll need 2 terabytes worth of space on that physical storage asset, and then we'll go ahead and create that 2 terabyte iSCSI target sitting on top of that physical storage asset. And then the advanced virtual, this is really where we get into some of the data protection functions of the StarWind software. And again, being able to, and I think one of the other benefits here to creating this using this software like StarWind is the ability to go ahead and mix and match these types of devices. I mean, as you can see over here, I've got some HA devices here. I've got some asynchronously replicated devices, and I've got some snapshot-enabled devices, all residing on the same storage boxes. And so I'm tailoring that virtual storage device to meet the needs of that application that I'm servicing with this particular piece of storage. Now, the RAID 1 mirror device, which is our asynchronously replicated device, allows you to go ahead and set up an active-passive scenario. What that means is you're going to have an active storage controller, we'll call it box A. Your initiators will connect to it, will use that storage, will issue I/O, block-level I/O to that storage. As those blocks change, StarWind is behind the scenes replicating that data to a second StarWind box. Now that second StarWind box, or second iSCSI target, so that's the other nice part about this is we'd like to be a StarWind box, but certainly one of the nice pieces of this is it's just any iSCSI target. So, if you want to, replicate to, say, an older piece of equipment or something to have as a backup, you certainly can do that. So what we're going to ultimately do here is go through the process of creating a scenario where you've got your primary, it's replicated to your passive box, which could be local, it could be off-site, really depending on the level of protection you're looking for. What that does is create that warm copy of your data so that in the event your primary were to fail, you simply take your initiators, point them at the passive box, reconnect, and bring your application back online. The next is the snapshot-enabled device. Now I've mentioned this earlier, this is really where we get into evaluating the volume for changes on a set schedule. And so, every 30 minutes, every 60 minutes, every 2 hours, we're going to go ahead and take a look at this volume, depending on what you plug in for the device parameters while you're creating it. And we're going to go ahead and create a restore point for you. So you've always got a scenario where you can roll this back. We do use, VSS, technology. So we've got a VSS agent that makes sure that when we do snapshot this data, that is indeed consistent. And so ultimately you wind up in a scenario where you've got a volume that can be rolled back. So if, data protection is key, if you've gone through the process of maybe building out a robust enough storage box where you don't need, say you've got redundant controllers, redundant power supplies, and you don't feel like you need to worry about spreading the risk out over a second box, but you are worried about data loss, this is an excellent option. This is also where we can create what's called a thin provision volume, and I'm sure you've all heard that term. And just as the name would imply, it's essentially a volume that's going to grow as you add data to it. So you'll give it an upper limit, and it will start off at 0, and then ultimately as you add data to it, it will grow. And again, that allows for maybe a more efficient use of those storage resources as you go. So that'll all fall under the snapshot and CDP device. And then lastly is the high availability device. And this is what I was describing and what you saw in my my last slide there, where we really are sort of taking this to a scenario where we're spreading the risk across a second storage asset. At this point, I want to create StarWind Box A and StarWind Box B. They'll be configured in an active configuration so that I can go ahead and have a seamless process if I were to lose one of these devices, if one of these machines were to go down, or if I had to bring one of them down. I'm in a situation where my storage will continue to be serviced. The I/O will continue to be serviced to my application service through the remaining box. Let me show you sort of what the creation of one of these looks like. Then we'll move over to seeing the iSCSI software in action, connected to an ESX setup and connected to a Hyper-V setup. So if I click Next, the very first thing it wants to do is it wants to wants me to tell it the IP address of the partner server. So where's the second iSCSI box that's been set up? And the login and password for the service. And it goes out and it makes sure that the service is there and is running. And it's also telling me that it's going to create a second target on that second box. And it's basically going to take the name I gave the original target and just add the word partner to the end. And now it's going to ask me for the virtual disk parameters. Now, if you remember, I explained earlier that what we're doing is we're taking a physical platform that's servicing these virtual storage devices. And so on the current server, this is the server that I'm currently creating this device on, I can go ahead and select which physical storage asset that I want to use. In this case, we'll just choose this, and we'll say disk 1. V2. And then on the partner server, which is the second server in this equation, I'm going to do the same thing, and I'm going to go ahead and choose which physical storage asset do I want to utilize here as well. And I've checked off the create new box because it's going to create 2 new virtual disks for me. And I'll just, for the sake of argument here, for the sake of the demo, I'll just go ahead and create a small 256 meg device. Now, the next thing it wants to do is it wants me to create a synchronization channel, or to select a synchronization channel. Now, again, when we start talking about virtual storage, it does rely on the physical. And so we do need to have a synchronization channel that's dedicated between these 2 boxes. So if you think about how multipathing works, it essentially goes ahead and issues or load balances, or in some cases just follows one path and waits until a failure to move over to another path, depending on the load balancing parameters that you set on the initiator side. So this synchronization channel is what's going to be utilized to make sure that you have active synchronization between the 2 storage nodes, so that these 2 boxes are always in sync. There's never a situation where one's different from the other, and that's why we generally tell folks to go through the process of making sure that if you're gonna do this through, say, some switching technology, maybe add a redundant switch and team a couple of these NICs. What most folks will do is they'll simply plug these 2 servers in with a crossover cable, just to make sure that they don't lose synchronization in the event that they've got to reboot a switch or something along those lines. And then the last part here is the initialization method. I could clear these virtual disks out if I was, let's say I was recycling a couple of old image files. I could synchronize data in one direction or the other, or in this case here, I'm just going to have it set up with 2 blank images, so I'm going to click Do Not Synchronize, as it won't be necessary, and finish. And it will go through the process of creating those devices for me, And once that is set up, and it will go ahead and set that up so that ultimately what I'll get is what you can see here. I've got my ESX data store here and its partner up here, and these things are indeed synchronized, so they're good to go and ready to use. So now what this is going to look like, from an application perspective, is something like this. And so obviously in my ESX environment here, what I've done is I've created several data stores, and obviously this assumes that you've gone ahead and set up your ESX host for using iSCSI. Whether you have ESX or ESXi, the methods are slightly different in terms of configuring and in terms of whether or not you have to deal with a firewall or not. But what I've got here is a couple of storage devices that I've set up that are highly available and are ready to use. And so if I were to look here at these devices and look at the properties of the devices that I've created, what I'll ultimately see here is I've got multiple paths to this storage. And as you can see, I've got a dead path from a NIC that I took out of one of these boxes. But as you can see here, I've got one box that's got two NICs in it. So this particular box here, where you can see the initiator or the IQN is the same. The only difference is I've got two NICs in here. And then here's my second storage box where I've got a single NIC in that one there. And basically what I'm doing is I'm load balancing the I/O out across these active paths to my storage using round robin. And then ultimately, depending on which side of that scenario a block gets written to, on the storage side, the StarWind service is managing the synchronization piece of this. So, if block A happens to travel for purposes of spreading a load out across these different paths, if it gets written to box A on the storage side, it's that block is then replicated through the synchronization channel down to storage box B, making sure that those are always in sync. So, ultimately I'm in a situation where I could lose one of these storage controllers and still be able to service my virtual machines. My virtual machines will stay up and continue to run until I've brought that second storage controller back online and it's resynchronized. And all of that happens in the background. A similar scenario when we're talking about doing this with a clustering technology from Microsoft. So what you're going to see here is I've got a Hyper-V setup here where I've got a cluster going, some clustered shared volumes here that I'm working, and I've got VMs running on this, and it's as simple as utilizing the MPI, or making sure I install the MPI role on Server 2008, and then ultimately through the Microsoft iSCSI initiator, making sure that I connect to both the primary and the partner target, and ultimately what that gets me is a multi-path device. So if I were to look down here and I were to find the Quorum drive, there's my Quorum partner, and if I were to keep going down here, I'll eventually run into my Quorum. This is on a separate iSCSI box. So there's the Quorum and the Quorum partner. If I look at this device from an MPIO perspective, you can see, again, I've got my 202 path to the storage, and then I've also got my .80 path to the storage. And I get to choose, again, here, my load balancing policy. So do I want to use round robin, which will load balance across? Do I want to use things like weighted paths or at least queue depth to go ahead and benefit me depending on the I/O patterns that are being thrown off by the virtual machines that are utilizing the storage. So again, very, very straightforward. And again, I think that it's worth mentioning here, and throughout all this, I want you to keep in the back of your mind that we're doing this with a software solution. So, the virtualizing the storage using StarWind software, the initiator side can't tell the difference. It looks just like, any other iSCSI SAN that you may purchase on the market. The idea behind this, though, is you've got the software gives you the flexibility that's associated with sort of tailoring this to your budget, deciding, what types of disks you're going to use, what type of networking you're going to use. And, for those of you that are already utilizing, maybe a fiber channel solution or maybe, another hardware-based iSCSI solution, that's great, and this is certainly something that can help augment that, by giving you some more choices and really the ability to go through the process of maybe building out a test and dev, a tier 2, or maybe adding on to a production SAN, utilizing something like this and really going ahead and being able to choose the hardware that you're going to use to build that out so that you can bring this in for a budget. So that's kind of the live demo aspect of this thing that I really wanted to bring everyone through today. And I think that as a recap, I think that the important pieces here are obviously when it comes to looking at a software solution for iSCSI. We're talking about gaining the reliability and scalability of the existing hardware, the hardware that you're familiar with, you've been running your enterprise applications on it for years. Sort of porting that over to a storage role and ultimately getting you into a situation where you're going to be able to choose what that infrastructure looks like. You're not going to have your infrastructure decisions dictated to you by your vendor. You're going to be able to pick and choose that. So, again, I think it's worth mentioning and really worth sort of hitting home on the ability to go ahead and make sure that you're able to have the types of options that I know we all want. As IT folks, we all want to be able to have options available to us without having to go through the process of dealing with, or having those choices dictated to us by a vendor, because generally speaking, when you start to have fewer options, things become more and more expensive. Now, with that said, I want to go ahead and transition into or take a look and see, if we've got any questions. And if we do, we'll go ahead and get to as many of them as we can, before, in the next couple of minutes. And then, like I said, any questions that I don't get to, I'll certainly, go through and reach out to everybody on a one-on-one basis after this. So the first question I have is, can I add HA after initial setup, say a year later? Absolutely. And that goes to, and again, speaks directly to the flexibility. So one of the things that you're able to do is set up a single box. If you decide that you need HA later on, you simply purchase the additional license, set up that second box, and then you go through the process of converting your existing storage into highly available storage. That's something that, when that time comes, you certainly let us know, and we'll get you down the appropriate documentation and make sure you understand exactly how that works. But the short answer to that question is absolutely. What kind of horsepower do those two StarWind servers have? What brands are they? So in this case here, I've got a couple of lab boxes, but generally speaking, and I talk about this, from the perspective of not only sort of as things sit today, but sort of looking down the road as well. When you're building out your sandbox, most of the boxes that you're going to utilize, you're going to be looking at, from a CPU perspective, a dual CPU, quad core type of scenario, where you're going to have enough CPU power there. A lot of the CPU overhead can be offloaded to the NIC cards if you spend some additional dollars there. The tow adapters or whatnot. But I think that the majority of that, you're looking at sort of somewhere in the sort of mid-range from a CPU, horsepower perspective. In terms of memory, there's sort of what you intend to do with the box now versus what you intend to do with the storage, a year from now. And so I always like to tell folks, focus on, a 64-bit OS with, between 8 and 12 gigs of RAM, and something that's ultimately expandable. Different factors will start to play in as you start to load these things up. You may choose, because of some limitations in your networking or some of the limitations around what you're going to be able to spend for the disk subsystem, you may choose to use RAM as an I/O cache, which is an option in StarWind. And so you're going to want to have the available memory there to be able to do that. So those are the types of things to consider when building out those boxes and the types of horsepower that they need. Can you use Server 2008 R2 Core? No, you can use Core, and one of the things that you would do there is you'd basically copy our installer over, run the installer from the command line on the Core box. It would do an install for you of the service, and then you can actually manage that from the user interface. So you can connect to install the user interface on a laptop or on a second box and connect to it and manage it from there. So it certainly can run on the Core. Let's see here. What else do we have? what is the limitation of the free version? Well, the free version, and I believe that there's a Victor. I'll send you over a link to the basically we've got a scenario where we've got a chart that basically compares the two. But the free version, as far as I know, and this is the sales and marketing guys would know better than me, but we'll certainly get you a solid answer on this. But the free version is some connectivity limits, so the number of active connections you can have to the free version. The free version also limits you to image file devices only, so there's no advanced features there. And I believe it's either a 1 or a 2 terabyte total storage limit that's on the free version itself. Can the SAN be in different buildings? And I'm assuming that Jeff's asking about that in terms of HA, and I'll assume that that's the case. They can be. Now, remember that from the perspective of performance, a synchronous channel is going to be there, and so ultimately you're going to be slowed down a bit if you don't have a very, very fast link between the two. Most of our cross-building type of HA setups involve having fiber connections between the two buildings, and having those types of fast connections. But if that's the case, absolutely. Asynchronous replication, which is sort of more of caters to those slower links, the active-passive setup, that actually can be accomplished over something as slow as a WAN link or a VPN type of scenario. We can get a copy of this presentation of you again at our convenience. Kenneth, absolutely. As a matter of fact, for those of you that did attend today, and actually everyone that didn't, you will be getting a link to a recording of this session so that you can go ahead and download it, share it with colleagues, or view it at your convenience. You'll also be getting an email from me, basically thanking you for coming to the event. If you want just the slide deck itself, just hit a quick reply button on that and just let me know you need the slide deck, and I'll make sure you get the slide deck as well. Let's see here. Another question. Are you using the Microsoft iSCSI initiator or one of your own? MS does not support dynamic disk and has a 2 terabyte limit on the basic disk size. Yes, and so we are using the Microsoft iSCSI initiator, to make these connections. Ultimately, our own initiator basically is more designed for ATA over Ethernet or fiber channel over Ethernet. It does not support persistent reservation, so it can't be used in, say, a Microsoft cluster. So ultimately, we are using our own. We're not using our own, and in this case, I was using the Microsoft. We do offer an initiator called Starport. So for those of you that are interested in, like I said, if you have a co-RAID device or an ATA over Ethernet type of device, or you want to connect a fiber channel over Ethernet, you can download the Starport product that way. And the last question that we'll take today, and then any others, we'll certainly get back to you on a one-on-one basis, is the trial software less functional or a limited period of time? The trial, so the 30-day trial is just that. It's a fully functional version of the software that will run for 30 days. So you'll get all the features, functionality, you'll get everything that you saw here today. You'll be able to set up HA, you'll be able to set up snapshot enable volumes, do everything that you want to do with the software without any limitations for 30 days. So that's pretty much how that works. Listen, I want to thank everybody for attending today. These events are obviously only as good as the numbers of people that we get to show up, and hopefully this was something that was both not just a commercial for StarWind, but somewhat educational from the perspective of if you're looking to build out some shared storage, if you're looking to implement some SAN technology, you'll consider a software-based iSCSI solution. If you have questions, if you want to approach me one-on-one, as I said, you'll get an email from me. Just hit that reply button if you'd like to chat further, and I'm happy to go ahead and chat with anybody on a one-on-one basis to really sort of maybe dig into your own scenario or what your own environment looks like, and maybe give you the benefit of some of the experiences that I've had. Really appreciate everybody's time. As I said, you'll get a link to the presentation or the recording of this session probably within the next 48 hours, I'd say at most. And if you do have questions in the meantime, I've put our contact information up there as well. Feel free to reach out to us directly, and we'll take it from there. I really appreciate everybody's time today, and look forward to hearing from you all in the future. Thank you.